Same company, same team, same question, two different answers. And that's not a bug. That's the whole point. Most RAG demos ignore permissions completely. You embed every document into one vector store, and anyone who can query it can retrieve anything inside it. In a real company, that's a data leak. Your intern shouldn't be able to ask a chatbot about executive pay and get a straight answer just because somebody indexed the document. So I built AccessGuard RAG, a multi-tenant retrieval system where permissions are enforced at query time inside the vector search itself. 6 Spring Boot microservices, Kafka for events, Postgres as the source of truth, OpenSearch for vector search, and Amazon Bedrock for the embeddings and the answers. Here's every document in this tenant and whether Bob can see it with the reason. Bob is on the engineering team, so the group grant gets him this one, but this one is denied. Same group, same grant. Denied because there's an explicit deny on Bob specifically. And deny always beats allow, no matter which path it arrives through. That's the case most implementations get wrong. Alice is on the same team. With no deny against her, she sees it. Now watch a permission change happen live. Dave has access to the employee handbook, so he gets a real answer about the time off policy. Now I revoke it. That writes to Postgres and publishes a Kafka event. The permission sync service then rewrites the access control metadata on every chunk of that document inside OpenSearch. Same user, same token. I haven't logged out and I haven't refreshed anything. And now the model says it can't answer because the document it needed is no longer something Dave is allowed to retrieve. The model never even saw it. Every query lands on an append only audit log. Who asked, what came back, and when. Here's Dave's query before the revoke with the handbook, and here it is after without it. And here's the revoke itself, timestamped right between those two queries. That's the paper trail a security review actually asks for. 3 things make this work. First, pre-filtering, not post-filtering. The access control check goes inside the vector search query, not wrapped around it, so the engine only ever ranks chunks you are already allowed to see. A document you can't access is never scored, never ranked, and never a candidate. Filtering afterwards is the leaky pattern security reviewer's flag, and it is very easy to write by accident. Second, group membership is resolved fresh on every single query. It's deliberately not baked into the token. If it were, the lifetime of that token would become a staleness window. Remove someone from a group and they would keep their access until the token expired. There is no such window here. Third, if access filtering returns nothing at all, the system refuses to call the model. Because a model asked about a document with no context will still produce something plausible from its training data, and the user can't tell the difference. That's a subtler leak than returning the wrong document. 6 services, 97 tests, a dead letter queue for failed permission syncs, and a reconciliation job that catches drift between Postgres and the vector store. Because Kafka guarantees delivery, it does not guarantee that your own consumer logic is correct. The code and the full write-up are linked below. If you are building RAG on private data, permissions can't be an afterthought.